Hello all, very good morning. Thanks for joining the session. Let me share my screen. Yeah. So let us start Docker today. Hope you are able to see my screen. Let us start Docker today. This is starting as a separate session, and whoever are now continuing for the microservices patterns and then for the SBMS one, they no need to do any payments. They will be allowed because it's aspect of your course. And separately, who are looking for a Docker and who joined for the Docker sessions, so they have to separately pay it. So fee is 1000 INR, and then the duration is 2 weeks. Duration is 2 weeks. However, as usual, so recordings will be provided. Recordings and material will be provided. Okay. However, let us see the course content and then the course plan. Fine. So here is the course plan. So how we will why we take the Docker and how we will cover the Docker. So what's the course plan? Let me open the course plan, course objective. Let me open the course objective. So the course objective is to containerize the any applications. What is containerization and all you came to know, but just in case, what is the course objective is? Course objective is to build a system which is shippable from one platform to another platform. So that means throughout this course, our focus is how we can build a shippable platform. Shippable platform. For example, you are writing the code in your machine, like let's say Python code you are writing in your machine. So how we will ship that code to another machine? For example, my machine, without installing any software in my machine, it should have to work. So basically a shippable platform we will build using this Docker. So as part of these sessions, to understand the Docker concepts, we will Dockerize the 5 applications. One is the website, which looks like the same. So we will Dockerize this static website. So how to Dockerize and all you came to know, static website. And then let us Dockerize the Node.js application, different applications. Let us Dockerize. So this is the Node.js application, which also we will Dockerize. So that means you came to know when we Dockerize a different applications. For the different applications, how we are writing the Docker file, what to be considered inside the Docker file is what you came to know. So when we see the different applications to be Dockerized. And then the third application is what will Dockerize the React.js application, which looks like exactly the same like this. And the fourth application is Spring Boot monolithic application we will Dockerize. So which looks like exactly the same, or maybe here we can use our own applications. We were build our applications like a Shopify application or Medilab Clinic application. So which UI also looks like the same, but the technology is the Java Spring Boot. So we will Dockerize the Spring Boot, Java Spring Boot application. And finally, let us Dockerize the microservices. So this is the goal of this session, objective of this session. So you will learn the Docker concepts and apply the Docker concepts for these 5 types of different technologies, so that you came to know how to write the Docker, how to Dockerize an application. So far we have discussed about Docker, right? So why Docker basically? Why we need the Docker? So Docker is required because of the Docker is required to solve the 2 problems. Problem number 1, if there will be an inconsistent environment, there Docker would be a great help to us. What is inconsistent environment? What is inconsistent environment? We may have seen several times, right? So in real time, how we will be is, we will be with the different environments. In real time, we will be with the different environments. For example, all the developers will work in one environment, testers will work in another environment, and then the uh, production or pre-production testing and all will be work in another environment. So likewise, production will be there in another environment. So likewise, we might have a different environments. So let me try to draw some diagram. So assume this is the just let me draw the diagram. So assume this is the dev environment, and assume this might be the QA environment, where QA people will work. Like that means they will test the application, functional testing they will use, and this is the UAT or pre-prod application environment, I mean to say, and here is the prod environment. Here is the production environment. So these are all the 4 environments we will have in the production, meaning we will have in the real time. Now in the production itself, there might be again high available environment. That means production itself is having the disaster recovery. So production disaster recovery environment, we call it as a DR, production disaster recovery environment. That means if this production down, this production will up. This will come back, then this will be down, and then it will be up. So that is what DR. However, now we have these environments: dev environment, QA environment, UAT environment, and then the prod environment. Usually the programmer or the developer, write the code in his machine, isn't it? The developer or the programmer will write the code in his machine. So let's say here is one programmer, right? And he will write the code in his machine. Let me take one diagram. Yeah, yes, I think this suits better. So he is the developer. He is writing the code in his local environment. Assume his local machine is the Windows machine. So there will be another developer, and there will be another developer. So these are all the developers, right, who is working on the code, meaning who is writing the code in their laptops, right? So this person, the first person, is working on the sign up user registration, assume, and then the second person is working on the login functionality, and then the third person is working on the uh, products functionality. Assume now all these features will be integrated in this dev environment. All these features will be integrated in this dev environment, and all those features will be, so now all these features will be integrated in this dev environment, and then it will be tested from here. So sign up, and then all these features, let me take it like this. So sign up, and then the login, then the products. So all these three features will be combined in the dev environment, and then this dev will be tested. Tested in the sense all the developers will use this dev, and then we will test the integrated functionality. That means first we will do a sign up, and then login, and then products. If everything is good, then the same code, we need to deploy in the QA environment. And if everything is tested fine and then okay in QA environment, then we should have to move the code to UAT environment. Now, if everything is okay inside the UAT environment, then we need to move it to the production environment. So this is what the flow, like how the build will be moved from one environment to another environment. Let's say here it is. So now, how do we move from one environment to another environment? How we will move the code? So in order to move the code, there are two things we should have to do. For example, if it is a dev environment, there will be one-time activity we might have to do, isn't it? What is that one-time activity is dev environment setup. So one-time activity we will do like environment setup. So one-time activity we will do like environment setup. So dev environment setup. As part of this dev environment setup, what we will usually do is assume this is a Java project. So first thing is what, when we take the mission, the first thing is what, we should have to install the Java. So probably we will set up the JDK, right? So probably we will set up the JDK in this mission. The first thing is what, if we would like to, uh, deploy these applications which are working on a Java application, just in case, then what we will do, we should have to install the Java there. So assume we are installing the Java here. So assume we are now installing the Java here. So this is the Java. This is the Java. So we installed Java here. Fine. Now, next is what, this application, once we install the Java, and this application, if we set up here, this application need to connect to a MySQL database, assume. Then what we need to do, we need to set up the MySQL as well. So let's say this is what the MySQL, let us take it here. So this is what the MySQL. Let's say we have to install the MySQL as well. Then Java is there, and then MySQL is there. Now assume we might need a server called Tomcat, where we will deploy this application. So let's say we want the Tomcat server. So this is what the Tomcat server. we need to install. It is a one-time setup. I'm talking about two things now. Environment setup is first part in that. So this Tomcat server we need to install and then set up. Right. Then what we need to do? Then what we need to do is the source code of all these guys. The source code of all these guys. We need to the source code of all these guys. We need to pull here. We need to pull here. For that, probably this is what the source code. So we need to get that source code onto this machine. So assume this is what the source code we will build onto this machine. Now all the source code we got. So let's say we got all the source code. What I would like to do is one moment, just let me take a one diagram. Yes. So assume all the source code that we got. So this is what the code, source code. So we got the source code. Now what we will do? So this source code requires the Java. This source code requires the database, and this source code need to be built using the Maven build tool. So we have to set up the Maven build tool as well. So this is the Maven build tool. So Maven we have to set up. Maven we have to set up. So using Maven, right? Using Maven, we might have built the source code. So this is the source code. We used Maven, and using Maven, when we build the source code, we will get a var file. We'll get a var file or jar file. So let's take some var file. Let's take var file. So var file or jar file will get. Let me take this icon, var icon. Sorry, one moment. Let me take this var icon. So once we build this code, then we will get this var file. So this var file we will deploy in the Tomcat. So this is the environment setup that we will do. It's a one-time activity. Okay, this is what the environment setup we will do. And assume this application, this application we deployed, right? And this application is talking to one UI called React.js. Assume, just in case, if it is talking to a UI called React.js, then what we need to do? We need to first install the Node.js as well. So this is a one-time activity. Installation is a one-time activity. Two problems we are not talking about. So in that, first problem is inconsistent environment. First, I am explaining you how the environment will be, first of all, before understanding the inconsistent environments. So this is the Node.js. On top of the Node.js, this is the Node.js. On top of the Node.js, let's say React.js is installed. So on top of the Node.js, assume React is installed. So let me take this React logo. Just assume on top of it, React.js is installed. Perfect. So this is one dev environment. Okay. Now, if you want to set up the QA environment, what we have to do? We have to do all these things, right? At least it's a one-time setup, but we have to do all these things. One moment. Right. So if it is a QA environment, then again we have to set up all these things. Though it is a one-time setup, but we have to take the one more EC2 instance in QA, and then we have to install the Java, install MySQL, install take the source code, and then at least not source code, but take the var file, whatever the var file build, right? So that var file, take the var file and then deploy the var file uh, in the application, and also set up the Node.js and then deploy the React application, right? So build happened here, we got the var file, the same var file we deployed to the QA environment here. But if we can understand the machine that we need to set up once, that means whatever the activities we have done here, like installing the MySQL, installing the Java, installing the Node, installing React, installing Tomcat, the same activity we have to do on the QA environment as well. For suppose this is one time setup only for sure, but we have to do this all. For suppose if you want to set up the UAT environment, again we have to do all these activity. So if you want to set up the UAT environment, again we have to do all these activity, like installing the Java, setting the Java home, installing the MySQL, installing Node.js, installing React.js, copy the var file from QA to this UAT, Tomcat, and then test the application. And same thing that we also have to do in the production as well. So production environment as well, we have to do the same thing. That means we have to install the Java, install the MySQL, install the Node.js, React.js, Tomcat, and in the Tomcat, whatever the var file we got from the UAT environment, that we need to deploy here. So though it is a one-time setup, as we have the 4 environments, 4 times we were done this Java setup, MySQL setup, Node.js setup, React.js setup, Tomcat setup, right? So repetitive task we have done 4 times, though it is a one-time setup, but each and every environment we have done that setup. If tomorrow one more environment will come, then again we have to perform the same activities in the one more environment. Okay, so this is what the one kind of problem why the environment is set up. Dev environment setup usually developers will do. QA environment setup will be given to the DevOps engineers to do the setup. By giving one documentation, the DevOps engineers need to be set up this QA. They don't know Java, they don't know MySQL, but they will follow the document and then they will set up the environment. Assume while they are setting up, so JDK Java 11 we have to use. They also used Java 11, but in place of Java 11, they used the JRE only, not JDK. Or maybe they used, maybe they forgot to, or they have not recognized, they have not noted that they have to use Java 11. Maybe they installed another Java. Or else assume Java is installed perfectly, but MySQL they have not installed perfectly. Or else Java they installed perfectly, but they forgot to set up the path, right? Anything can be happened while doing the repetitive activities in the various environments. Maybe QA they were done perfect setup, but while setting up the UAT they might forget one or two steps, at least one step they might have forgot. Due to that, QA will work in different way, maybe UAT also will work in different way. Assume QA is working fine, but in the UAT one functionality is not working fine. Assume, right? Then what we need to do, we need to debug. So that functionality is working in dev, that functionality working in QA, but the same functionality not working in UAT. So developers will start debugging why it is not working, and later on time, after spending hours of time, if they realize that code is good, but the problem is with the environment setup, that is looks really weird, right? Because the developers development effort wasted, that means their time wasted, and then environment is not set up properly is what they have detected, which is not good. So UAT environment is not properly set up, meaning definitely they will get a doubt on prod setup also, whether it's set up successfully or not. So what I mean to say is, if we do a repetitive task in various environments, though it is a one-time task, as we are human beings, there might be a chance of going or chance of getting some errors, right? There may be a chance. There may be a chance of getting the errors in down the line environments as well. However, assume this is the one case. So what is the flow here? On dev machine, we will set up the Java, we will set up the database and React.js, Node.js, Tomcat. Then from all the developers code, we will all the developers code we will take into this dev machine, and then we will build the code using the Maven, assume for a while, and then we will get the war file. That war file will be deployed into the our Tomcat server. And after the dev environment tested well, then the only war file will be moved to QA environment, and in the QA environment the war file will be tested. This is one scenario. But in another scenario, what will be happen, if we move this war file directly to the QA environment, right? What will be happen, the developers, whatever the changes they are doing, those changes will be in this war file, isn't it? And that developer changed, the developer changes, they will do a keep on changes basically. This is the war file version 1, assume, and this is the war file version 2, 3, 4, maybe upgrade to different versions as well, based on the developers they are progressing on the code, isn't it? So again, which var they have to copy into this QA next deployment if they want to do, which var they have to deploy here. So that is the reason usually we also will copy the source code again from the different branch to this machine, QA machine. That means we will maintain the dev related source code in dev branch, and then QA related source code in QA branch. So again, we will pull the code from the QA branch. So this is what the QA branch is. Again, we will pull the source code into the QA machine using the branch called QA. So using the branch called QA. For example, assume we are taking the source code into the QA machine from the branch called QA release, from the branch called QA release. Whereas the code will be taken into the dev machine from which branch of the source code repository? From the branch called dev release. Let us take this branch as a dev release. So this is a dev release. Now from the dev release branch, the code will be taken onto dev machine. From the QA release branch, the code will be taken onto QA machine. So that means again the code build also will be happened on the QA machine and then deployed into this Tomcat server. Then whatever the war file we got, that war file again will be moved. Whatever the war file we tested here, that war file will be moved to the down the line environments and then tested there, right? And from here the war file will be moved to the UAT, and then from the UAT it will be moved to the production, and then it will be tested. So this is the usual flow what will be happening in the real time. Okay, now in this flow, this is the usual flow what will be happening in the real time. Now in this flow, if we don't use Docker, we'll get two problems. We'll get. What are those two problems? Let us now discuss. So one is the inconsistent environment problem. So why we are using the Docker is now what we are discussing. In that process, we were seeing the various environments, how they will be in the our real time. Now, what is the problem of this inconsistency? So developer who has built an application that works fine on his own environment, but when reach the production, there might arise certain issues with that application. This is common thing, isn't it? Assume this sign up is working fine in his local environment. When he is doing the sign up meaning user registration functionality is developing, this developer is developing in his machine, that user registration functionality working fine when he is developing in his machine, and when he tested in his machine it works very well. But when he moved the code from here to dev machine, then the user registration is not working. So what does it mean? User registration not working meaning what? So first we need to understand the user registration flow. So user registration flow, user sign up flow, user registration flow is what we need to understand. So what is the user registration flow? Number one, user, a user can be created by the admin or 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 through the self registration. So there were two situations we have based on the business. We will have the two ways of registrations. One is the admin registration, second one is the self registration. If you go to any hospital, right, you assume you went to hospital for the doctor consultation very beginning time, then in the front desk the receptionist or maybe the front desk admin will collect all the details from you. What's your name, what's your email, what's your mobile number, all these details first she will collect, and then she will do the billing for you. I mean, give the doctor consultation and take the bill related to that. That means what she might have done, guys, can you please mute? Thanks. So that means what she might have done, she might have done the user registration. So that is the admin registration. For example, when you go to Amazon website, right, there you will register yourself. We will register ourselves. That is called the self-registration. So user can be created by the admin or through the self-registration. Then what is the next flow? A user verification. A user verification email should trigger, right? So next, once user clicks on the verification link, right, the email verification should be done, and redirects to reset password page, and fourth thing is what? After password reset successfully, then user should be able to log in. This is the sign up flow. So this sign up flow working fine when the developer tested in his own environment. That means user created in the database, email triggered for that user, and then email verification success, reset password page came. That's it. Not login, because login is not his job, but at least reset password page came. And he is not able to log in because login is implementing by someone person. But at least assume the login page he got. This is the user sign up flow. Everything worked well in his mission. Now his code he moved to the dev environment, which is an integrated environment where all the pieces of functionalities will be integrated and then tested together. Now what happened? The same flow should have to be executed well on this dev environment as well. But what is happening, unfortunately, email is not triggering. Email is not triggering in this dev environment. Whereas email triggered successfully from when we tested from his machine. But when the same functionality moved to dev and then build the var and then deploy the var in the Tomcat, var meaning application build. So deploy the application in the server. When tested, the email is not sending. Why? Why meaning, why meaning, the email, in order to send the email, assume SMTP settings. What he used in his local is the Gmail SMTP settings, assume. But when we move to dev, we should have to use the application specific SMTP settings. So he did not change that SMTP settings, and then he was with the Gmail settings only, whereas the Gmail support or mail opening support not there from this machine, or mailbox is not, gmail.com domain is not reachable from this machine. So we got the error of bouncing the emails back. That is the problem. You got it? What happened? Everything is worked in his machine, but when it is moved to this dev environment, it didn't work. I have just taken one example, but there may be any other cases as well, where it worked well in one machine, whereas it didn't work well in another machine. So maybe the case is like this also. Everything worked, all this functionality worked in developers' local machines. And when we integrated this all functionality, everything worked well in dev. But when we move this, when we give the source code, I mean, when the code will be taken from the dev release branch into this machine and then build it using the Maven, we got a war file, everything worked well. But when the code will be pulled from the QA release branch into this QA machine, and when again we build the code and again we got the war file, but this is not working with the email triggering functionality. What might have been the issue? The issue might be whatever the dev code may not be there in the QA release code, isn't it? That means QA branch is not merged with the all the developers code. That is the reason maybe when we have pulled the QA code into this QA machine, it didn't working, it is not working with the email triggering functionality. So these are all called inconsistent environment problems. So usually we were faced this problem since so many years, and in your day-to-day life also in your company you might facing these issues, right? So this is what the environment inconsistent problem, right? So what is dev and then what is QA? QA meaning this is one more machine server, this is one more server. Dev meaning this is one more server. So different servers we were set up in the real time, different environments. So this, assume this is one more virtual machine, like one more laptop you can consider. So which is with the network exposure, meaning the these machines will be accessible over the network. Yes, that is what I would like to explain you first. First, listen the problem statement. Then how do we provide the solution with the Docker? We will see. First, listen the problem statement. Okay, understand the problem statement first, because interviewer will ask you, why? Can you justify why we need to go for the Docker? Can you please justify with an example why we are going for the Docker? So interviewer will ask the question. First, we need to define the problem, understand the problem first, then let us see how we will move it to the Docker. Fine. Now the problem is, first problem is what? Inconsistent environment. That inconsistent environment problem we will solve using the Docker. I believe now you might understood what is the inconsistent problem mean, isn't it? So something working in the dev, whereas something not working in the next environments or next machines is called what, the inconsistent environment. This is the first problem. And then second problem is what, second problem is what, virtual machine for starting multiple microservices. If we take the microservices case, then what we need to do, there is a concept called microservices. Maybe that concept discussing is little too early here, but what I would like to explain is here, if Terraform is a different one. Terraform is for infrastructure provisioning. That is to create these machines only. Docker purpose is different. Terraform purpose is different. Terraform purpose is to set up the infrastructure, whereas Docker purpose is to inside that infrastructure build the Docker containers. That is the purpose of the Docker. Okay, however, now this inconsistent environment problem, how do we solve with the Docker, right? How do we solve with the Docker? This inconsistent environment problem, how do we solve with the Docker? Assume we have the same dev environment here. So we were done all this setup, right? All this setup we were done, and then we got the var file. But this var file, rather running inside the Tomcat server, this var file, what we will do is, let us build it as a image. Let us build it as an image. First, let us set up the Docker. Now listen carefully. So Tomcat and all is there, right? Similarly, in this mission, let us also set up the Docker. Now how it resolved with the Docker, I'm trying to explaining to you. So let us install the Docker. Now what we will do, once we got this var file, then using Docker, we will create the Docker image. We will create the Docker image. So assume these are all the images. So we will create this Docker image. So assume this is the Docker image. Okay. Now this Docker image will be run inside the container. Now this Docker image will be run inside the container. There is a concept called container. What is container and all? Just not worry about what is container, but assume what is container, meaning inside the container we will run the application, like how inside the Tomcat we run, right? Now the Tomcat will be inside this container. Now the Tomcat will be here, and inside this we will run this application from this Docker image. So we will run the application from this Docker image. So earlier, that observe the difference. Earlier direct var file we deployed here, but now what we did, using Docker, as we have the Docker here. So what we have done, whatever the var file we got here, that var file we build as an image first, right? So the var file we build as an image, and this image we are running as a Docker container. What is image, what is container, we will see later on time. But if you can observe carefully, the var file we are converting into Docker image, and that Docker image we are deploying or running as a Docker container here. Now, what is the beauty of it? What benefit we will get? What benefit we will get is, let us say, let us go to the QA environment. Let us go to the QA environment. Now in this QA environment, again we have taken the code from the QA branch and all, right? Because of what, earlier we don't know the versioning of the code, meaning what version of the dev we need to go here. But with the introduction of this Docker, the Docker images versioning is possible. So with that Docker images versioning, what we will do here is, we won't install the MySQL here, we won't install the Java, no, not required. Node is not required, source code is not required, Maven not required, var file is also not required, this is also not required. Then what is required? What is required is, there will be a registry. There will be a registry. That means the centralized registry or centralized place. Assume this is the registry. So this Docker image will be pushed to this registry, and from this registry, so Docker image will be pushed to this registry, and from this registry, let me keep this registry here. So from this registry, the QA machine will get the image. So whatever the image we have here, that image we will keep in this registry. So from this registry, our QA machine will take this image, and this image will be run using the Docker. So when that image will be run using the Docker, we will get the container. Of course, inside the container, we also will get the Tomcat, and then inside the container, application will start working. See the beauty of it. See the beauty of it. Now, if this image will work in the dev, 100% this image will work in the QA as well. Why? Because we have not done any extra environment setup like installing the Java, Node.js, MySQL. No, we have not. All these tools setup has been done in the dev environment only. And then using those tools, we have built one Docker image. And then using that Docker image, we have created the Docker container, nothing but which contains the application inside in it. And that application we tested well on the dev environment. The same Docker image on which we have tested successfully the application features, the same Docker image, we just move to our QA environment. Now what happened in QA environment? The same Docker image is deployed as a Docker container because Docker is here. So that Docker can understand this Docker image, and then it created as a, yes. If you want to deploy in new code, okay, let me explain that. So Docker image, this Docker image will be go here. Now this registry we are using here, right? This will support the image versioning. So developer is writing the code, keep on, and then they are generating the image 2, image 3, image 4, right? After certain implementations, they might suggest us, now you have to deploy the image 5 in your QA. Now that image 5 we can deploy in the QA. That means revisioning, versioning of the images is happening in this registry. Earlier, the versioning of the war file is not there anywhere. That is the reason we again pulled the code. But now versioning of the images are happening in the registry. So if they tell what is the version, no, image won't override because versioning is support here. These registries will keep the old image 1, image 2, image 3, all the images it will keep here, no override. If it will be override, always only one image here. No, this is the image registries. Image registries will keep all the versions of the images. So with that, whatever the version number we will mention, with that version number, we will take that Docker image. We'll pull the Docker image on this QA machine. And however, the platform is Docker on this machine. The platform is Docker on the dev machine. Dev environment, the platform is Docker. QA environment, the platform is Docker. So whatever the image is created here and then running here, definitely that should also be run here, right? Now then what will happen? In the next environment? In the next environment, what will happen? So again, this is the UAT environment. In UAT environment, no need of this installation, no need of this source code deployment and all, nothing. The simple thing is what? We just have to install the Docker here, and from the registry, we should have to just to pull the image. From the registry, we should have to just to pull the image. Now what will happen? Again, this image will come to this environment, and when we run that image using the Docker, so we will get the application extracted inside this container, and then application start working well, right? So this is what the UAT. So definitely whatever the image is working here, that image 100% will work in the QA environment because the same image we are moving here. So there is no problem of environment inconsistency issues will come, right? So this is the benefit of Docker, right? So means the software the software code we are shipping from one machine to another machine, from one environment to another environment. That is the reason Docker is said to be an open source. Docker is an open source shippable platform. Open source application shippable platform. Docker is an open source. Open source for what? Open source is used for what? Shipping the applications from one environment to another environment, right? So yes, if the QA, assume we deployed the image in the QA, if the QA will find the bug, then what we will do, we will report that bug to the developers. So this is the image number, and in this image number we have seen these issues. That issues will be reported to the dev environment. Now developers do what? Developer will revert their image number 10 with the image number 2, and then they will reproduce the issue here, and then developer will fix it. And once they fix the issue in the image number 2, then they also will verify the issue in the image number 10. If the issue is still there in the image number 10, then they will suggest the QA to take the image number 11 at this time. So image number 11 will be taken here and then deployed here. So likewise, the Docker will help us a lot to ship the code from one environment to another environment. So how the Docker is different from AMI? So if it is an AMI, what we will do, entire machine snapshot we will take. That means this entire machine will be copied with all this Java installation, all this setup. There we are not shipping the code from one environment to another environment. Just we have taken a snapshot of one environment and then created another environment. If tomorrow we want to, we want to run a new image, then what we have to do? We have to take a new image here and then take a snapshot of it, and then again we have to run that AMI. That means what? In the AMI, if you want to take a new image, every time we have to take the new snapshot. But if we use the Docker directly install on an EC2 machine, every time we can take a new image. Okay, so that is the difference. So that's all from this Docker demo 1 session, folks. So any questions for me?
Sir, I have one question.
Yes.
Sir, if dev environment, it means developer tools. Then the QA environment is a means another tool, or this is a tester. And UAT, and what is a UAT? Means I try to understand, but still not is getting.
Okay, UAT meaning what? Trial run of our production environment. Production meaning all the customers like you, me, we are using. We are the customers, external persons. Okay. We are using. We are the customers, but they don't directly give that application to us. Before giving the application to the end customers like you and me, they were run a trial runs in their company environment. So that trial run environment is nothing but the UAT.
Okay. So means as a developer, we need means focus on the developer in the environment.
Correct. Exactly correct.
Yes, sir.
Yes.
Sir, now I have one question. That is, now for an example, I have sent two Docker images to the QA environment. Okay. Out of two, in Docker image one, I got one issue while doing the testing. Then I reported to the developer that there is one issue in the QA environment Docker image one.
Correct.
So now in the a developer needs to be fixed in the Docker image one only, right?
No. First developer will check what, reproduce the issue in the Docker image one. Okay. If the issue they will find, maybe by the time they might have created the different Docker images as well, right? In their dev environment.
Exactly. Yeah.
So they will also verify whether this issue fixed in the latest Docker image or not. If the issue fixed in the latest Docker image, then they will suggest the QA people to use the latest Docker image.
Okay.
If the issue is not fixed, issue is also found in the Docker image 5, then what they will do? They will do the code changes and then build the Docker image 6. That Docker image 6 will be suggested to QA. to
Means
deploy.
they will create a new Docker image and send it to the QA environment, right?
Correct, correct,
Okay,
correct.
means whenever they found the issue and they will fix it from the developer side, it will create a new Docker image and send it to the QA environment. Is it?
Exactly correct. Exactly correct.
Okay.
But not directly developer will send to the QA environment.
Okay.
Rather, the
Putting
image.
it to the in the repository.
Correct, correct. Exactly correct.
Sir, how to install Docker images in number of instances, sir?
No,
It is the
no, only
there is
one
a
time.
15, there is a 15 instances. You will manually install everywhere, or you will do any automation?
Automation we can do, like Terraform we can use. Terraform we can use, and then we can set up the machine with the Docker.
Oh,
Fine. Any more questions, folks?
So how do you one question, sir.
Yeah.
Let's say now when you install new Docker image onto a box, will it uninstall previous installations, or how is it happening?
No, actually, we are installing the Docker images with the tags, isn't it? So, guys, can you please mute? I mean, I definitely will answer all your questions, but I'm muting all of you. Okay. So now, assume here it is running a tag. Here in the Docker terminology, we called them as a tags. So assume now tag 1 is now running. So due to some reasons, we want to get the tag 2.0 as well. Then what we will do? The tag 1.0 specific container we will stop. Tag 1.0 image will be still here, but let us get the image with the tag 2.0, and then that tag 2.0 image will be run as a container again. Got it? So tag 1.0 image is here, tag 2.0 image is also here, but tag 2.0 image is only running as a Docker container. Got it, right? Am I addressed your question?
No, sir, I don't understand about the installation.
Sir, I have a question. So how do we manage the environment specific configuration with the help of Docker?
Yeah.
Or is it something else?
Correct. In order to manage the environment specific configurations, what we need to do is, usually here we will use the Docker compose files. So Docker compose files, in Docker compose file, we will pass the environment specific configuration. For example, just in case, let me showcase you one Docker compose file which we were written. Maybe applications, dev applications. Sorry, this is the Kubernetes one. Docker apps, middle app, pre-clinic app, Docker compose file. Yes. So in this Docker compose file, we will build the Docker compose file specific to one for QA, one for dev environment. So once we got the Docker image here, using the Docker compose file, we will run this Docker container. So in the Docker compose file, we will mention what is the image and what container should have to be created and what its port number and all, and username, password, database name and all. So this Docker compose files we will maintain per environment. So using that Docker compose file, for example, if it is QA Docker compose file we will use, and then we will create these containers from the Docker image. Got it?
Yeah, got it. So one more question, sir. So like how we are set up for a dev and QA environment, right? Same way we can do our same setup in our local also, if my understanding.
Exactly correct. This Docker we will install in our local. So Docker we will install in the dev. So as the underlying platform is Docker in your local, underlying platform is Docker in the dev environment. So whatever it should work in our local, definitely should have to work in the dev also, because the same Docker platform we are using in terms of Docker image building.
Yes, in that case, right, if multiple developers want to work on, so how this hacker help us and how we can segregate, like let's say I work on one piece of a code and some person will work on another piece of a code. So how it will work?
Yeah, because that's the reason here what we are doing. we are merging all the developers code into one branch called dev release. That means dev release is now having a combination of all these codes, right? Login code, developer 1 code, developer 2 code, developer 3 code. All the developers code is there in this dev release branch. So that developer code we are building as a var file, and using that var file and using the Docker file. So there is a Docker file actually. I forgot to mention here. So using the Docker file, the image will be built. The Docker image will be built. So here is the Docker file. So what I mean to say is, in the dev environment, all the developers source code will be merged from the source code repository, because all the developers will push their source code to this repository, right? Once they test their functionality in their local machines. So don't think like each and every developer will create a Docker image and then give to dev environment. No, the outcome from the developer is a source code only to this dev environment. That means all the developers will test their code with the Docker by creating their local Docker image. Inside the Docker image, they will test. Yes, everything is worked fine inside the Docker image. That means whatever the code they have used to build the Docker image, that code is fine when it works well with the Docker platform. So that code only they will push to the dev release branch. Likewise, all the developers will push their code to the dev release branch. So that code we will get into dev environment, and then we will build the var file, and then using the Docker file, we will create the Docker image. Got it? Huh?
Yeah, I have a question over here. So let's say we have a use case that where I would like to install some text module in a Node.js. Okay, that's specific to in my current code chain or whatever it is. So,
Correct.
but another developer, right? They don't want it because as it is still in my development or still in my testing, right? So, how it will be segregate in a Docker?
So application is like this. If it is the React.js or Node.js, so usually applications are like this. So this is the UI module or UI application. This is the backend services. Assume this is the Docker image. Now we have to build the separate images for this one. For a UI application, one image, backend application, one image, database is one image, and then we will club all these images together. That means club all these images together, meaning these images will be run as a containers. So that container will be communicated each other. So container to container communication we will establish. So if any other person don't want the React.js, they don't get that React.js image from the Docker registry. They will only take the backend image and then they will test it. Clear? I may answer your question.
Yes, got it.
Yeah.
Thanks.
Hello.
Yes.
This is Reddy speaking, and I'm a full stack Java developer. So, should I possess knowledge on Linux? Are you going to cover as part of this course, or how it is?
No, Linux won't be covered. Directly, I will jump to Docker concepts only. So Linux is not required for this Docker actually. The focus what we will do is, in this Docker installation, Docker setup, Docker file writing, Docker images, Docker containers, and container to container communication, container networking, Docker volumes, and Docker compose. This is our focus. This is what we will test. In order to do this entire course content coverage and then we will use the EC2 machines with the Ubuntu platform. So I don't think no need to go back to the Linux and then learn all the Linux things here. Nothing, not required, because here we will use the Docker commands, not Linux commands.
Oh, okay.
Yeah.
Thank you.
One thing, sir.
Yes.
I want to learn Docker and Kubernetes from you. So will we have a Kubernetes another session?
Yeah. Once after this Docker is completed, likewise, let us also plan a Kubernetes for 20 days course. Once the Docker is completed, let us plan for the Kubernetes.
Sir, I have some knowledge on microservices. So
okay.
Just basic knowledge. So I don't know how to integrate microservices with Docker and Kubernetes. So using these two sessions, will I understand that completely, sir?
Yes, fully you will understand. Correct. fully you will understand. Because right now, Spring Boot microservices session is going on at 7 a.m. For them also, till only Docker is there in the course content. Maybe they also curious to know what will happen in the Kubernetes. So this course will cover how to Dockerize the microservices, and the next course will cover how to deploy the microservices, the Dockerized microservices in the cluster. That is a separate course. Let us plan.
Sir, first time I am attending your course. Will I get all these recordings and these diagrams, whatever you are showing?
Yes, you will get. So I will create a Google Classroom. In that Google Classroom, I will upload this material plus the Docker, the images and whatever I'm drawing here. And the recordings will be reached to your Google Drive by the backend team. So every day they will upload the recordings.
Okay, thank you.
Sir, is there any interlink between QA Docker server and dev server?
No interlink. Both are isolated. So this is a different mission. Assume this is a different mission and this is a different mission. The only interlink is what? Using the same image.
Only
The
Docker
image,
images, sir.
exactly, Docker images.
Okay.
Yeah.
Sir, I have one question.
Go ahead, please.
Hello, sir.
Yeah, your voice is slow actually. Can you please be loud?
Hello, sir. Is it okay?
Yeah, this is fine. Yeah, please.
Yesterday, the Spring Boot on Microsoft class is completed, sir.
Yesterday, we have completed this triangular pattern.
Triangular pattern, because it's not opening. I mean, it's waiting from long time, but the link is not opening, sir.
No, they might have already updated to you guys, right? Let us start the Docker, because our
No, sir. No, we are not updated. We are.
Oh, really? That is really bad. Actually, what is the plan? Next we will create in our next pattern is what? Discovery server, API gateway, config server, right?
Yeah.
And then Grafana and all. So these are all we will build on the Docker platform.
Okay.
Yes.
So you will get a very good realistical exposure.
Okay. But the link is have some problem. Morning 6:30 onwards, I'm trying about it still, but not opening. But I'm calling also, but nobody is not updating from this.
Yeah, I thought they might have been already updated to you. So sorry for that inconvenience. But I will probably for the microservices patterns, we don't have any Telegram group, right? That is the problem. Maybe causes the communication gap. Let me create it. Actually, I will create.
Okay.
Yeah.
So what time
I missed it, sir. I missed it from 2 classes. Can you please upload it from 2 classes for me?
Sure. I'll do that.
Okay, thank you.
Okay.
So the timing of the course will be 7 to 8, sir?
Yes, 7 to 8. Correct. So timing of the course will be 7 a.m. to 8 a.m. And this won't covers any Docker Swarm till the Docker Compose I will cover. So the course will cover Docker and then the Docker Compose, no Docker Swarm, because it's not required. No one is using nowadays. Everyone is using the Kubernetes because of there is one problem in the Docker Swarm. However, I'm not covering that as part of this. Only focus on the Docker and then Docker Swarm. Okay, folks, that's all from my side.
Sir, this is Shesha.
Sir, one more question. Hello, sir, one more question. That Spring Boot or Microservice Docker will be covering one. Otherwise, we can't pay more again. 1,000 rupees can pay this one.
No. Actually, who joined for the microservices patterns? Who joined for the SBMS 1 and then MS patterns? Who joined? For them, this Docker is as part of your course content. So you no need to pay any extra fees. Okay, but the persons who explicitly came to learn the Docker, they have to go through this registration process.
If I can join design patterns of Spring microservices.
Yes. Okay, design patterns. Design patterns is not scheduled, right?
I mean, Spring Boot micro design patterns.
Yeah, you mean to say microservices patterns, correct? Yes. Then no need to pay. No need to pay.
No, sir. I haven't joined.
sir.
I don't know about that particular thing. Now that you're, I understand that there is something going on. So is it possibility if I join now? Or
Yeah. You can join. Only one pattern called Strangler we completed. So only one pattern called Strangler we completed. There were other patterns actually. So you can join. It is okay. Only Strangler pattern you might missed. That you will get the recording.
When is the batch started, sir? How many classes have been completed?
Yeah, it's 1 week. 1 week class is done. 1 week, 10 days class is done actually. 10 classes, I believe. 10 classes done.
Okay, sir. Okay, sir.
On my side is a Spring Boot or microservice, sir.
That's okay. That's okay. Spring Boot microservices. This is your course actually. You should be. Docker should be, your prod architecture. So no need to pay any extra.
Okay. Next Spring Boot microservice batch when it will start, sir?
We planned actually maybe after this. Maybe in the August it might start. Maybe if any one of the slot will be empty, then we are thinking to start it in August. Let's see.
Okay, thank you.
Okay, so no CI/CD pipeline integration won't cover actually, but for the knowledge purpose I will showcase. But complete CI/CD
integration with Docker, only connection.
Correct. For the knowledge purpose I can show that, but entire pipeline explanation, Jenkins explanation, that is not covered. Just for knowledge purpose I will showcase the pipeline integration. Okay, so duration.
I have one question. Sir, this class today is the first class or it has already started?
Docker session. This is the first class of the Docker. So this session is included by the Spring Boot microservices folks and also microservices patterns members. So this
what time microservices pattern timing?
Same 7 a.m. to 8 a.m. So as part of the microservices patterns only, we are covering this Docker as a separate section. Once the Docker is completed, then in the let us go back to microservices patterns. In the microservices patterns, there is a 12-factor principle. So while understanding that 12-factor principle, as we already completed with the Docker, you will easily understand these 12-factor principles. That is the plan.
Sir, I want to join this also. So what is the fees and how to pay this microservices pattern?
Yeah, actually, I will give one number. Can you call to the backend team who is dealing, my batches? I'll give that number directly. Just note it down here, and I'll type here. So 9246212143. So this is the number. You can contact and then check the details actually.
So this 34 or 43?
It is sorry, yeah, you are right. 212143. Yes.
Okay.
You are right. 212143.
What is the fees for microservice patterns?
It is, I believe, 4,000 or 3,000. 3,000, I believe. Yeah.
Okay. And how many days it will go for microservice?
Yeah, microservices patterns initially planned for 20 days, but it will take 20 to 30 days because Docker itself is taking 15 days, right? So it will go for 30 days for sure.
Okay, sure. And so one more thing, microservices is useful only for those persons who are learning Spring Boot and microservice?
No, actually, microservices is a general architectural style. Not only Spring Boot guys. For example, Python members are there, or .NET members are there. They also can attend and then listen the microservices patterns. But the underlying platform here I am using is the Spring Boot microservices. So it will be more beneficial to Spring Boot microservices guys, at least Spring Boot guys.
Okay. Thank you so much.
Sir, one query I have.
Yes.
I have basic knowledge of Linux and OpenStack cloud computing. Is it related to Docker here, or this is actually a separate thing and Docker is separate?
Uh, I didn't understand your question. If I understand your question properly, you are coming from the Linux background.
Yeah, Linux and OpenStack cloud computing.
Oh, okay. OpenStack cloud computing. Yes. Then Docker is different one actually, because OpenStack also, yeah, that is OpenShift, right? So yeah, Docker is different one. Altogether, it is a different one.
Okay.
Sir, will you cover microservices, all these patterns in Spring Boot upcoming batch, sir? All these things?
Yes. Upcoming Spring Boot microservices batch, I will cover the microservice patterns plus Docker. Yes. Yes. Okay, guys, I have to join to another session now. Thank you so much for your interest. Thanks for joining the session. See you tomorrow at the same time. And then let us start. Yeah.
Sir, Shesha here. One question, sir.
Yeah, Shesha, please.
నాకు స్ప్రింగ్ బూట్ మెటీరియల్ డౌన్లోడ్ చేసుకోలేకపోతున్నా సార్.
Okay, just let me check it right now. Just let me check it.
Babu EDA999@gmail.com.
Sure. Just let me check it. Just in a moment. Let me check it. Let's go to SBMS1. And first, let me verify. Okay, first let me tell you how you are downloading. So let us go to the Spring Boot material. Where is that Spring Boot material? Let me go back. Spring Boot material. Yes. So now once after we open the Spring Boot material, first of all, we have to open each and every document to download. Not all the documents can be downloaded at a time. Each and every document we have to open and then click on the download button. Not all the documents.
Okay. Thank you. I got it now.
Okay. Fine. Okay, folks. I am stopping.
Sir, small requesting. He's Hari. Yeah. Yesterday the CI/CD pipelines. How many classes is complete, sir?
Two demos were completed.
Okay. Thank you.
Okay, thanks. So the duration of this Docker is 15 days.
Okay.
At the side, Vivek, sir.
Yeah, hi Vivek.
Yes, sir. How many classes in completed in MS pattern?
Only meaning only one pattern completed. That means 10 classes completed. One pattern meaning microservices patterns demo plus the Strangler pattern, both around 10 classes.
Okay. Because I want to join a MS pattern also, sir. So
Sure. Just
start. We have another 20 days for on the remaining topics.
Yes, correct.
Okay.
Correct. Yeah. Okay, folks. Thank you so much for joining the session. See you tomorrow at the same time, 7 a.m. to 8 a.m. Thank you so much.
Thank you.
Thank you.